Use the graph to estimate the left and the right Riemann sum for the interval 0 to 8 using 4 subdivisions. The closed interval is given. This means the left number is a equals 0, and the right number is b equals 8. To compute the Riemann sum, we need to know the height f of x sub k and the width delta x, where delta x is always b minus a over n. Since we're using 4 subdivision, n equals 4. So this is 8 over 4 or 2. Once we have the width starting from a, which is 0, we would add the step delta x to get to the next x value. And then we add delta x, which is 2, add another 2, add another 2. And so we end up with 4 subdivisions. This means that we will have 4 rectangles. Using the left endpoint for the first subinterval from 0 to 2, the left endpoint is 0. We would go to the graph to get the height, and then we draw the rectangle with that height on the interval 0 to 2. Similarly, for the next subinterval, we use the left endpoint, which is 2. Then we would go to the graph to get the height of the rectangle. Then we draw the rectangle on the interval 2 to 4. For the next subinterval, 4 to 6, using the left endpoint 4, we would go to the graph and then obtain the height and draw the rectangle using that height from 4 to 6. For the last subdivision, we use the left endpoint 6, go to the graph to get the height, and then use that height to draw the rectangle from 6 to 8. We will use these 4 rectangles to estimate the left Riemann sum. For the first rectangle, the height is approximately 5, and so we have 5 times the width, which is 2, plus for the second rectangle, the height is approximately 1.1. It is a little bit above 1 times the width 2, plus for the next rectangle, the height is also approximated as 1.1 times the width 2, plus for the next rectangle, the height is approximately 2.1 times the width 2. This means that we can factor out 2 and add the height 5 plus 1.1 plus 1.1 plus 2.1. Notice that we have 4 terms in the sum. This is the left sum using 4 rectangles. Evaluate this, we get 18.6. And again, this is the approximate left Riemann sum. For the right Riemann sum, for each of the subinterval, we will use the right endpoint. So from 0 to 2, the right endpoint is 2. We go to the graph and then use that height that we just touched the graph to draw the rectangle. From 2 to 4, similarly, the right endpoint is 4, so we would go to the graph, use that height to draw the rectangle from 2 to 4. From 4 to 6, 6 is the right endpoint, we would go to the graph, use that height to draw the rectangle from 4 to 6. And from 6 to 8, the right endpoint is 8, we go to the graph using that right endpoint, and then use that height to draw the rectangle from 6 to 8. And so the right Riemann sum will be the sum of these area of the 4 rectangles. Denote the right hand sum as R, and then we use 4 subdivision. We know that each of the rectangle has a width of 2, so we're going to factor out 2. The first area is 2 times the height, but the height is 1.1. For the second rectangle, 2 times the height, but the height is also 1.1, plus for the third rectangle, 2 times the height, but the height is 2.1. And then for the last rectangle, 2 times the height, and it looks like the height is about 3.4 or maybe 3.3. If we use 3.4 for the height of the last rectangle, then the right Riemann sum is approximately 15.4. In many applications, a better result is to average both the left and the right sum. So we take the left Riemann sum plus the right Riemann sum divided by 2, which is 18.6 plus 15.4 divided by 2, and we will get 17.